measure. This is a measuring device. Obviously, we don't want to use this measuring device, but here we'll try to measure the electrode potential of half cell. The sad news is that we cannot measure the potential of individual half cell. That means we can only measure the difference. And that is nothing but EMF. So if I know potential of this, I can know the potential of this. If this is, let's suppose A and this is B, or let's say anode, this is cathode. This is my convention. So if I know the potential of anode, I can get the potential of cathode for a given metal. For example, I have zinc here, I have copper here. But the trick is, how do we know this first value? At least there should be first one, right? For whose value I know, that becomes a base, and from that we can find out the values. Correct? So what should we know? So if we know the potential of one, then we can find the potential of another. But how to find the first one? Now hydrogen will come as savior. Hydrogen told, okay, I'll save you guys. Now as per convention, standard hydrogen electrode, for standard hydrogen electrode, my potential is 0, right? So I'll say, using the platinum metal, actually hydrogen becomes H2 plus, H plus actually, right? H plus aqueous, and for this E is 0. You talk about oxidation reduction, it's all same, right? You talk about E of H plus to H2, that will also be 0 in presence of platinum. Right? Please note, this is assigned value. Actually, that is not the value, but as per the convention, this is as per convention. As per convention. Always hydrogen is always in dicey, right? It's metal or non-metal, again a question. So chemists thought, let's take hydrogen as 0 potential, right? You go from H2 hydrogen to H plus ions, or from H plus ions to hydrogen, doesn't matter, right? The reduction potential is 0, right? The reaction is hydrogen will take one electron and becomes hydrogen gas. So this is 0 assumed value. And please note here that the estimated value of this is assumed, right? These are all assumed values. The estimated value is almost 4.4 volt from H plus to H2. That is the actual value, that is the experimental value. Right, at STP at 298 Kelvin, this is the absolute value. But just for the basis of comparison, hydrogen potential is declared to be 0 at all temperature. Please note, it is declared to be 0 at all temperature. But actually, it is not the case. And that is actually can find out, because for example, you can do some maths. You have some, let's suppose, metal A and metal B. You try with one combination. When you try metal B and C, you get some values. You try A and C, some values, right? So A minus B, you know, B minus C, you know, A minus C, you know. So using these three equations, you can actually find the value of A, B and C. So what I'm trying to say is, if you want to find the electrode potential of three half cells, you take 3 half cells. And using 3 half cells, you produce 3 different cells in 3 combinations. You can experimentally find the value of this, and with these 3 equations, you can use this maths to find the value of A, B and C. So with that, it is found that the value of hydrogen potential is 4.4 actually, but it is assumed to be 0 for convenience, because anyway, when you want to find we are not much interested in the electrode potential of half cell. We are generally interested in the electrode potential or the EMF of the whole cell. So there we anyway do cathode minus anode, right? So anyway you're subtracting. So for example, if it is 0, instead of 0 it was 4.4. This was the actual value of cathode. anode also, let's suppose y plus 4.4 was the actual value, right? But we are assuming it is x and y because we have assumed this to be 0. But when you find the E of cell, you say cathode minus anode, you say x minus y, and this gets cancelled. 4 plus 4.4 minus 4.4. So that's why it doesn't make much difference, because end of the day in the electrochemistry we are interested in the EMF of the whole cell. So there anyway we say cathode minus anode. So this value, whatever is there, actual value gets subtracted, right? And you get 0 value. So even if you're assuming 0, it doesn't make many difference. And that's why it was declared to be 0 at all temperature. But actually it has a value of 4.4. Hope I didn't confuse you guys. H plus 2H2, there is a reduction potential of 4.4 volt, but it's declared to be 0 at all temperature just for convenience purpose. Because in chemistry we are interested only in the electro EMF of the cell, and in EMF of the cell we generally say cathode minus anode. So even if there is a value here, it gets cancelled. And we are saying that we are trying to find the value of any electrode with respect to hydrogen, right? So it becomes easy if you say that this guy is 0. And we call that standard hydrogen electrode. Please understand this. This is called standard hydrogen electrode. SHE. Standard hydrogen electrode. So the reaction here is, you have my hydrogen ions in the aqueous solution. It gets electron, forms hydrogen gas. And that is the gas. It goes off. Okay, so for this my half cell will be in platinum H2 become H plus, or reverse way, let put it this way, H plus became H2. For this my E will be 0. So in this case, this hydrogen electrode or standard hydrogen electrode, it will consist of a platinum electrode. This is a platinum electrode here, and this is coated with platinum black. It is coated with platinum black, right? Platinum black. And this electrode is dipped in an acidic solution. This is acidic solution. And this is, please note, is 1 molar. 1 molar H plus, maybe HCl or any acidic solution, right? And we bubble pure hydrogen gas. See, pure hydrogen gas is bubbled through it in this direction. Right? It comes in this direction like this. Right? And please note, the concentration of both reduced and oxidized form of hydrogen, that is H plus and H2, that is maintained at 1 molar. So this is also 1 molar. This is 1 bar actually, that's correct, STP. And this is maintained at 1 molar. H plus ion concentration is maintained at 1 molar. I'll explain why in the next equation, why the concentration of the electrolytes matter, right? That we'll see. Now the question is, why did we use platinum here? Why? What is the role of platinum electrode here? See, platinum is inert. Platinum is inert electrode. Correct. So PT is inert. Since it is inert, it won't participate in the reaction, but it will provide surface. It will provide surface for oxidation and reduction reaction. It will provide surface for reaction. It will provide a platform where the reaction can happen. Right? Also, it will provide a platform for conduction of electron. Whatever electron is generated, for example, now hydrogen gas will become H plus, right? So electron will be released. So platinum surface will help this reaction. Correct? So platinum provides a surface for both oxidation and reduction reaction. And it also provides a mechanism for conduction of electrons. So that is my standard hydrogen electrode here. Correct? I have a hydrogen gas here, the platinum rod, and this is the acidic solution H plus. So hydrogen gas becomes H plus.